Static stability defined. Let's consider a parcel of air displaced by a small distance vertically from its initial position. We're going to define the following terms: stable equilibrium, unstable equilibrium, and neutral equilibrium by considering what happens to the parcel after that initial displacement. We can argue by analogy from a marble inside a bowl. We can see in this situation that the forces existing after the displacement tend to return the parcel, or the marble in this case, to its initial position. So the restoring force in the case of the marble is gravity, and as we push the marble up the sides of the bowl, gravity is acting downwards to return the marble to its initial position after the displacement. So that's a stable equilibrium. So in the real atmosphere, that will be a case of we lift a parcel of air and it finds itself cooler than its environment. So the buoyancy force will be back downwards to its original position. An unstable equilibrium is one where we give our object a small perturbation and it runs away from its initial position. So in this case we have a marble on the top of an upturned bowl, and any small displacement will result in gravity taking the ball away from its initial position. In terms of the real atmosphere, an initial vertical displacement will result in a parcel of air that is warmer than its environment, and so that will be an unstable equilibrium because the buoyancy force will be upwards and will move the parcel away from its initial position. Finally, we have a neutral equilibrium where there's zero net force after the initial perturbation. In the case of our marble, we've got a surface and you push the marble along and there's no force either way to either return it to its initial position or accelerate it away. In the real atmosphere, this would be equivalent to giving a parcel of air a small perturbation, and after that perturbation, the parcel's still at the same temperature as the environment, so there's no buoyancy force in either direction. So a layer is said to be statically stable, neutral, or unstable if, after a parcel from that layer has undergone a small upward displacement, the parcel is less buoyant, colder than its environment, which means it's stable, at the same temperature as the environment, which means it's neutral, or more buoyant, that is warmer than its environment, which means it's unstable. And so the parcel returns to its original position if it's stable and less buoyant than its environment, remains stationary if it's at the same temperature as its environment, or accelerates away if it's more buoyant than its environment. So stable environments inhibit convective motion, neutral environments neither inhibit nor encourage it, and unstable environments means that convection can occur for parcels that are perturbed with a small displacement.